Hello and welcome to part 18 of the series on how to create a chess game with ReactJS. In this part we are going to finish the queen. In the previous part we have worked on moving the queen horizontally and vertically. In this part we are going to move it diagonally. To get started we are going to open up our code editor. We are going to open up the referee, and right here we have the movement for the top right, bottom left and top left. And as you can see we only have some logging. So when we open up our console right here and we move our queen in that direction, we see that we get some logging for that direction. We're going to start with the top right section, or with the top right function. We are going to look at how we did this for the bishop. Let's see, right here we have upright movement. Let's take what we have right here, and we are going to use that as guidance for creating the function for the queen. So right here, let's comment everything out right here. We are going to create a pass position, and this will be of position type, and we are going to say that it is initial position.x plus I, comma, y equals initial position.y plus I. So do you know why we add a plus for the x and a plus for the y? If you want to think for a second, you can pause the video right now. We are using the plus sign 2 times because we are moving to the right, so that is a positive increase in x value, and we are moving to the top, which is also a positive increase for the y value. That's why we add the I to both of the values. Next we check if the pass position is equal to the desired position, and we can do that with our function, which we have called right here, same position, pass position, desired position, like so. If we are at our destination, we want to check if we can move to there or if we can hit an enemy in there. So we say if this dot tile is empty or occupied by opponent, pass position, and then the board state, and then team, like so. We want to return true, and else, if we are not in our desired position, we want to check if we are moving over an obstacle or if we are moving over a free tile. How to check if we are moving over an obstacle? We just say tile is occupied, and then we want to check for the tile which we are passing. If it is occupied, we just break and we don't do anything. Let's remove this and test if our code, which we have written right here, is working. Save it up, and if it works, we should be able to move to the upper right corner. Yes. And we should also be able to not move over pieces. That's correct. But we should be able to hit an enemy piece. So we try to move over the enemy piece. That's not working. Let's try to hit it, and we can take it. Nice. So we now have the upper right corner, or the upper right direction for the queen working. Now we actually can do the same. Now we can do the same for the bottom, left and right, and the top left. We can copy over this piece right here. And we need to check the I value. Again, if you want to try to figure this out yourself, you can pause the video right now. To make this right, we need to add the I value to x, that's correct, but we are moving down. So we need to subtract it from the y value, like so. For the rest, it's the same. So next up we have bottom left, and for bottom left we need to subtract the I as well. And for the x value we also need to subtract it, since we are moving to the left. And then last but not least, we have our top left. And the top left we need to decrease the x value as well, but we need to increase our y value. So let's check this out. If we refresh the page and we move the queen to here, we can take. Let's take the bishop to here, we cannot take. We can take. And as you can see, you get the idea, it's working. So that's great. But there is one minor thing that we are going to improve, and that is the following thing. we now have a separate if statement for each direction. So top right, bottom left, and top left. And this can actually be done in one if statement. Again, if you want to try to find a solution on your own, you can pause the video right now. So the solution we are going to implement involves creating a multiplier. Just as we did with the vertical and horizontal positions, we made a multiplier, and that multiplier defined if we need to go to the left or to the right. For the diagonal movement, we are kind of doing the same thing. So let me show you how we are going to do this. Here in top right, we are going to rename this to diagonal. And the thing is, we don't need this if statement anymore. We want to check if we are moving diagonally at all. And this is diagonal for the upper right. We could put all those if statements inside of one. I don't think that's really clean. What I think is a better solution in the long term is removing the if statement as a whole. So this may seem a little bit weird, but we are going to remove this one, and we are going to move everything one line back, save it up. And the thing is, we are now having one past position for every diagonal. And depending on the diagonal, we are going to assign a value to the x and to the y, or to the I value. So just like with the horizontal and vertical movement, we had a multiplier. Same thing here. We're going to create a let multiplier x, and we're going to say multiplier y. What is our x multiplier? Well, we are going to use that from here. If our desired position is smaller than the initial position, that x, it will be negative, otherwise it's positive. Same goes for y, only then we want to know the y value instead of the x value. So now we have two multipliers. How are we going to do this? Well, really simple actually. We just say I times multiplier x, and right here I times multiplier I, like so. And then we can just remove everything. So the top left, we can remove it, the bottom left, and the bottom right, like so. Remove that white space or that white line. Let's see, save it up and cross fingers to check if it works. We can move to there still. We still get the login for the top right, but that's okay. Let's see, can we still take a piece? Yes. Okay, that's good. Can we still move over pieces? No. Okay, that's good because we've never got that. Can we move onto pieces of our own? No. So as you can see, it's just working. So how does this work? Well, to clarify it, we had 4 directions: upper right, bottom left, and top left. And for each of those directions, we had a hard-coded I value. If we move to our bishop, we can still see them. Let's see, our bishop is right here. As you can see, we have here a plus, 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 minus, 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 and minus, plus. So those minus and plus values are actually variables. Those are the only things that are changing in the if statements. The rest of that is the same. Everything till here, what I've selected right now, is the same. The only thing that's changing is the position, or the past position. So if we update this, and we update it with a variable, we can make a really efficient function which just handles all 4 directions. So that's really great. We can remove the diagonal from here. We are going to combine the horizontal and vertical movement with the diagonal movement. This one is going to be tough. If you would like a challenge, I suggest you pause the video right here and try to think of a solution. If you want to follow along, just skip 3 seconds and we're working on the solution. you see the thing is, with horizontal movement, we only change the x value. The I value or the y value, as you can see, stays the same. So what does this mean? This means that the multiplier for the y value should actually also be 0. So how does this look? Well, if we, for example, take a look right here, we are going to write this out into an if-else statement. So to keep it simple, we're going to say if desired position.x is smaller than initial position.x, multiplier x is equal to -1, else if desired position.x is bigger than initial position.x, the multiplier x is equal to 1. This is actually what we have written right here. So we can comment this out. And right now, the ternary operator that we had, we do have that right here. There is a third option, which is that the x value is not changing and that we are moving along the vertical axis. So that third option is the else statement. If it is not smaller, so if it is not moving to the left, if it is not bigger, so if it is not moving to the right, then else it should stay in the center. X value is unchanged. If this happens, our multiplier x will be 0. What does this mean? If we look into the past position, we see that our initial position at x gets multiplied or gets added with I times the multiplier x. So if we move to the top left, we have a -1 times I that goes into this number. If we move to the right, we have I times 1 and that goes into this number. If we are moving along the vertical axis, we have I times 0 and that goes into this number. Let's write it out. We have I times -1. If we go to the left, we have I times 1 if we go to the right, and then we have I times 0 if we stay in the center or in the middle. So here we have middle, here we move to the right, and here we move to the left, like so. And as you can see, the initial position .x is being changed depending on the number or on the direction. Let's write this. As you can see, when we move to the left, our initial position at x gets added with I times -1. So this could be -1, -2, -3, -4, up until -8. Right here, if we go to the right, it could be 1 times 1 or 2 times 1. So this will be 1, 2, 3, 4, 5, up until 8. The last one, if we stay in the middle, it will be initial position at x plus I times 0. And what happens if we multiply a number by 0? It will always be 0. So we can actually just remove this and it will be the same. So now that we have this third value, the x value is unchanged, we should be able to make vertical movements without having this right here. Want to try it out? Let's remove it, save it up, and let's refresh the page and check this out. If we move up, we can move up, move down works, cannot move over pieces, and we cannot move under pieces, and we can take other pieces. As you can see, the vertical movement is working. We can do the same for the horizontal movement. For the horizontal movement, we are going to create a multiplier y, and the multiplier y, we're just going to put this right here and uncomment this out just like we did with the x. The multiplier y will actually be pretty much the same as this one, except we are just going to compare the y values. C like so. And then we need to change this to Y as well. And then it's exactly the same story. We can't just leave it like this, because if we save this up and remove horizontal from here, save the code, refresh the page, we should see that we can move horizontally. Nice. You may wonder, well, why didn't we implement this to start with? Because this is a lot shorter and a lot more efficient than what we've written first. Well, the reason is, to be honest, I didn't know this was possible. While making these videos, I come up with solutions on the fly, and while developing and implementing those solutions, I come up with better solutions. So that's why the solution we have right here is coming so late. The good thing is, by doing this you can learn, and you can learn to create those solutions by yourself. So by constantly looking at your own code and trying to improve it, you'll get better at it. And with this being said, I want to end this episode right here. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!